So today in psychology, we're going to talk about the different research approaches that psychologists use in order to study the effect of something, whether it's the effect of memory on different gender types, the attention to different objects, things like that. So in order to show you how we do that, I'm going to talk about the different approaches using a product that many people might be familiar with. So how many of you have heard of the product called Baby Einstein? And if you've heard of it, how many people feel that it is that it works in improving children's vocabulary? So why is it important that we study stats? Well, it helps us evaluate claims that companies or people will make, particularly Baby Einstein. And in fact, Baby Einstein owns 90% of the baby media market, and almost a third of all babies in the U.S. have at least one of these products. And 75% of the top-selling infant videos on Amazon.com make educational claims, one of them being that these will teach your children about language and logic, patterns and sequencing, analyzing details, and more. And because psychologists are also scientists, we actually use the scientific method in order to help us evaluate claims. And we'll go through those steps in the next couple of slides. Research ordinarily begins with careful observation. Let's say that I let my kids watch Baby Einstein DVDs, and I make the observation that, wow, my kids have really large vocabularies, and because they watched Baby Einstein DVDs, it must be because of that. Unfortunately, there's one problem with that, and that a lot of times observations that we make lack control, they're highly subjective, which means I have really nothing to back that claim up. Subjectivity aside, this is a very good place to start. So step one in the scientific method is make an observation. Eventually, we're going to go beyond the observations to try to explain the patterns that we see. We go beyond the observation by making a hypothesis. And this is a specific or testable statement about the relationship between two or more variables. We made an observation that we feel like Baby Einstein DVDs improve children's vocabulary. So now we're going to actually put our necks on the line, and we're going to make a hypothesis that Baby Einstein DVDs increases children's vocabularies. Our hypothesis has been set, so we need to start collecting data in order to support our hypothesis. And we're going to need some variables that we're going to measure. And variables are anything that can take on different values. So a variable can be a condition, it can be an event, it can be a characteristic, or it can be a behavior. And we actually observe them by either manipulating them, controlling them, or measuring them. Variables can take on two different forms. They can be discrete variables, or they can be continuous variables. So discrete variables can only take on specific values. For example, whole numbers. So no other values can exist between them. So if we look at our Baby Einstein DVD, a discrete observation or variable that we would use to measure and test our hypothesis would be to test and measure the number of days per week children watch baby DVDs. So the only possible values are between 0 and 7, discrete. Not 7.5 days, 0 to 7. We could also test continuous variables, or continuous observations, and these can take on a full range of values. For example, they're a number that can go out to a decimal place. These are infinite numbers. It's from 0 to infinity. So again, using our Baby Einstein DVD as an example, we can measure the time children spend watching baby DVDs. So this is slightly different. So a baby or a toddler may watch 1.35 hours each week, while another one might watch 3.85 hours each week. So those are continuous variables. They're on a continuous scale. Variables can be further subdivided into specific types of variables, and basically these are variables that have particular characteristics or qualities. There are two types of variables that are always discrete, and those are nominal and ordinal variables. Nominal variables are used for observations that have categories or names as their values. For example, when we're entering data into a statistics computer program, a researcher might code male participants with the number 1 and female participants with the number 2. But those numbers merely identify the gender category for each participant. The numbers do not imply that men come first and females come second, or that men are better than women. Another example of nominal data is your major in college. So you can be engineering, you can be poli-sci, you can be psychology. We can't really put values on these, they're just categories, so we can actually... Ordinal data, on the other hand, which is also a discrete variable, are observations that have rankings. So when you run a race, you get the variable of having a rank. You come in first, second, or third. So in team sports, for example, your team finishes the season in a particular place or rank. Whether your team goes to the playoffs is determined by its ranking. So you can be ranked 15th and not make it to the playoffs. You can be ranked first and make it to the playoffs, but you can't have a ranking of 3.8. Therefore, they're discrete variables. Interval and ratio variables are continuous variables, which again means that we can measure it on a continuous scale. 1.1, 1.2, 1.3. With interval data, we assume that the distance between the numbers or values is the same. For example, time is an interval variable because from 1 minute to the next is exactly the same. It's always 60 seconds. There is one exception to interval data where it's not continuous, and that is with survey variables. There is an exception to interval data not being continuous, and that is with survey data. If I ask you to measure your happiness on a scale of 1 to 5, we call it an interval scale because the distance we assume from 1 to 2 is the same as the distance from 4 to 5. It's discrete instead of continuous because you can't have a ranking or a rating of 1.5 on one of those survey scales. Finally, there's ratio variables. Ratio variables carry the same criteria as interval variables, so they're continuous, the distance between the numbers is equal. However, with ratio variables, they actually have a meaningful zero. So in the case of distance, you can go 1.5 miles or you can go no miles, and that zero actually has a meaning. The meaningful zero in ratio variables actually means that it has the absence of something. So if I talk about distance, you can go no distance, so there's an absence of distance. And that's different than interval data because for something like temperature, which is an interval variable, it doesn't mean the absence of something, it just means another variable, another temperature. One final note, and it's going to be particularly important when you start to do SPSS. Interval variables and ratio variables are sometimes called scale variables, and you'll actually see that in SPSS. So just know that a scale variable is any variable that falls under the criteria of either interval or ratio. Okay, so we know that when psychologists want to make a claim, they first observe something, maybe in the real world, like we did with the Baby Einstein DVDs, and then they make a hypothesis. So now they have to test it, and they need to collect data, and the data is going to be some type of variable. Okay, so for the Baby DVD, we've made an observation, and then we've actually come up with a hypothesis. And we know with that we need to test it, and we're going to test it by collecting some data, and that data is going to be some type of variable. But how do we go from making a hypothesis to collecting that data, we actually have to have some definition of what do we mean when we collect that data. If I get a number of 25, what is that actually going to mean? That number 25 is going to mean something different depending on how we define it. We're going to need to be truly specific about what that variable means. And so we need to operationally define it according to the procedures we used to measure or manipulate that variable. This may be confusing, but let's take an easier example of what we mean by operationally defining the variable that we're testing. So let's take violence as an example about what it means to operationally define a variable. So how could you operationally define violence? We could define it as the number of times that somebody hits another person, or you could define it as the number of times someone yells at another person, or you could define it as the number of times someone makes a nasty comment, either about somebody or to somebody. So each of these definitions describes a violent act in its own way. But now I want you to think about the number of times you each did one of those in the last month. And I bet you would get very different values. So therefore, in order to say that something produces a violent act, we need to be very specific about what we mean by the term violent, particularly when we want to say these are how many violent acts were done. With our variables operationally defined, we can now do step 3 of the scientific method, which is hypothesis testing. This allows us to draw conclusions about whether a particular relation between variables is supported by the evidence. Usually it's an if-then statement, so if babies watch Baby Einstein, then their vocabulary increases. Likewise, the corollary will also help support our claim. So if babies don't watch Baby Einstein, then their vocabularies will not increase. So we've made our hypothesis, we've tested it with different variables, and now we're going to draw our conclusions. So we're going to look at our if-then statements and decide which one of those either supports our hypothesis or refutes it. Because we followed the scientific method, our empirical conclusions are based on data rather than opinions or beliefs. Furthermore, hypothesis testing can help form a theory. So in this case, an overarching theory that we might be working towards is the effect of passive exposure to repeated stimuli, such as in Baby Einstein videos, on vocabulary acquisition. The last step in the scientific method is to replicate as well as to report our results. It's important to replicate our results because we want to make sure that our results are not because of a fluke or due to chance. Maybe the babies in our study were super smart, and so it showed an increase in vocabulary, or maybe they were super delayed, and that affected our results as well. We also report our results because it keeps scientists honest. By reporting our results, we're actually telling the scientific community that we believe in our results. We're also inviting the academic community to replicate our results in the hopes of them finding the same outcome. There are several important criteria that help us to distinguish between casual observations or speculations and actual scientific evidence, and those criteria usually fall on the researcher. One of the criteria for good research is the researcher should have objectivity. And what I mean is that data should be gathered and analyzed with objectivity. In other words, researchers should strive not to be biased by their preconceptions. Complete and total objectivity is, of course, impossible, but it is an important ideal. As much as possible, psychologists want to try to remain unbiased when collecting and analyzing data. So let's take our Baby Einstein example again. And if I were a researcher and I were doing this study, it would be very difficult probably to remain unbiased, because if I want vocabulary to increase, maybe I'll report an increase even if there is none. I might not do it intentionally, but I might see something that's not really there. Knowing that objectivity can be a problem, there are actually ways to get around this. So a lot of time, researchers who are doing things like maybe vocabulary where they have to code it, they will actually have a research assistant doing the coding for them that is not aware of the outcome expected, and so therefore they can be a little bit more unbiased. Objectivity and analysis is pretty much the same thing. As you will find out, there are a number of analyses that can be performed on data. And if one doesn't find something doing one analysis, we have to resist the urge to perform a whole bunch of other analyses until we get the results that we want. Again, it may not be that we're trying to be deceitful, it's just that humans are biased. Another criteria for good research is to have a representative sample. As you can imagine, the results of a study are going to depend very much on the children or people who participate in that study. So when we run a study and we look at a group of people, we're not really interested in just that group. What we're interested in is those results that we can then generalize to a larger population, a larger group of people or children or whatever. Populations represent the group that we want to generalize our findings to, but it would be really difficult to study the entire group. So if we're doing our study, our Baby Einstein study, our population would be probably all of the babies in the United States. But think about it, that's very difficult, time-wise, it's expensive to do that. So basically what we're going to do is we're going to take a sample from that population. A sample is a subset of that population, and we hope that it's representative of the bigger group or the population. Taking a subset from the population of all United States babies, we could look at all babies in New Hampshire. However, this may still be a difficult task. So maybe we could actually take a convenience sample, so we could maybe take a sample of babies from just Manchester. It's easily accessible to where we are here at UNH Manchester. The best way, though, to make sure that our sample is representative of the larger group or the population is to take a random sample. A random sample means that everyone in a particular population has an equal chance of being chosen for the study. As you can probably imagine, it can be difficult to actually get a random sample. So if we decide to actually take a convenience sample from the city of Manchester, we have to be assured that it is probably representative of the population of the U.S. as a whole, but we will also take a random sample from the babies in Manchester. The worst possible scenario is a biased sample. An example of that would be if we took all of the boy babies from the city of Manchester. I know this is an over-exaggeration of a biased sample, but you can tell that it's not representative of the babies in Manchester, New Hampshire. The final two things that we need for good, sound research is reliability and validity. Researchers want to make sure that any measures they use in their study consistently measure the same thing. That's reliability. For example, if you took a personality test yesterday and then again today, the results from the two tests should be roughly the same. If they are, that's a good measure. It's reliable. Likewise, we want to make sure that the measure that we're using is valid. And this is really looking at the extent to which researchers are really measuring what they think or say they're measuring. For example, if we wanted to assess fifth graders' math knowledge, our tests wouldn't be valid without questions addressing addition and subtraction. So if you've ever played darts and you want to get the bullseye and you have 3 throws, but you keep hitting a spot outside the bullseye, you are consistent in hitting the spot, so therefore you're reliable. However, you're not valid in hitting the bullseye, so therefore you are not accurate. So this is important because you can have reliability without validity. If I keep putting a 10-pound bag of potatoes on a scale and it keeps reading 5 pounds, is this reliable? Is it valid? It is reliable because I keep getting the same weight of 5 pounds. However, because I told you it was a 10-pound bag, it is not valid. So the scale is not measuring what I think it should be measuring. Interesting to note, you cannot have validity without reliability. You can have the opposite, reliability, without validity, but the converse can never happen. There are two major research designs that psychologists use, both correlation and experimental studies. You probably learned about these studies in your introductory psychology course. However, let's review them because it's incredibly important to understand the differences between the two types of studies. And again, we're going to use our Baby Einstein DVD idea or hypothesis that we formulated as an example of the two different types of experimental designs. So the first type of design is a correlational study. And this type of study examines information about two or more variables without the researcher's intervention. So the researchers don't have to manipulate any of the variables that they are interested in. They're just looking at relationships between existing variables. For example, let's look at the amount of sleep each night that adolescents have and their depression. We could also look at quality of daycare and attachment outcome. We could look at maternal alcohol consumption and severity of birth defects. These are things that we're not going to actually intervene with. We're not going to actually change somebody's IQ level because we can't. We're not going to give mothers alcohol to see what the birth defects are on their children. We're just going to kind of observe them and measure them. And we're going to see if there's any relationship between the two. So a correlation between two variables is the relationship between them, and we may see a positive correlation. So an increase or decrease in one variable will be matched by an increase or decrease in the second variable. So if we're looking at aggression and hours watching violent TV, as the amount of hours that people or teenagers say watch violent TV, the more aggression they will exhibit. So that's positively correlated. As one increases, the other one increases as well. Likewise, you can see the opposite effect. As one variable decreases, the other one will also decrease. A negative correlation is when one variable will increase or decrease and the other variable will do the opposite. So take, for example, empathy and hours watching violent TV. So as the hours of watching violent TV increase per night, empathy goes down. So that's a negative correlation. And finally, there are also things such as no correlation at all, which means that there's no relationship between the two variables. So for example, the hours watching violent TV and somebody's height. As you can see from the random dots on the graph, that there's no relation between the two variables. The major limitations of correlational studies is that they do not permit us to determine cause and effect relationships between variables. We can talk about the association between the variables, but we cannot say that one variable causes another to increase or decrease. The major reason we cannot make cause and effect conclusions is that there can be other variables that we didn't study or control for that have an influence on our outcome variable. These other variables are called confounding or intervening variables, and again, they interfere with our results. So let's take, for example, the association that truly exists between ice cream sales and murder. These two things have been found to be positively correlated, which means that as ice cream sales increase, so do the incidences of murder. Now you may look at these two things and the association and think this is ridiculous, they cannot be associated. And yet statistics show that they are positively correlated. However, as I said before, we can't infer that one causes the other. And that's because there are other things that also might be involved for the association. One of the variables that may be interfering with this relationship is the variable of heat. And it's been found that as heat increases, so do ice cream sales. And as temperature increases, so does aggression, which then leads to the possibility of murderous acts. And because both of these two things have a relationship, and yet outwardly it's ridiculous, think about how much more difficult it might be to interpret a positive correlation with something that's a little bit more subtle. So we're going to use our Baby Einstein DVD example, and I'm going to show you a study using the correlational design. This study was conducted in 2007 by Zimmerman and colleagues, and it explored the relationship between media exposure, specifically watching baby DVDs or videos, and language development for children younger than the age of 2. Zimmerman and colleagues wanted to know if there was a relation between media exposure, particularly Baby Einstein DVDs, and language development. They randomly sampled families, particularly parents of children, using the telephone, and parents answered questions about the typical amount of time that the children spent watching children's educational TV, children's non-educational TV, baby DVDs or videos, and adult TV. They also estimated how much time their children spent being read to and listening to stories and music. The researchers also measured language development using a measure called the MacArthur-Bates Communicative Development Inventory, or CDI. Higher scores indicate more advanced language development. They found there was an association between watching baby DVDs, particularly Baby Einstein, and language development, but not in the direction that everybody was claiming. In fact, they found that for each hour per day that babies watched baby DVDs, it was associated with a 17-point decrease in CDI scores. But remember, one of the limitations of correlational studies is that we cannot make cause and effect conclusions. So even though the researchers found an association or a link between watching DVDs, baby DVDs, and language development, we cannot say that baby DVDs caused slower language. If we do want to make causal statements about baby DVDs and language development, we need to conduct an experimental study. An experimental study involves manipulating some aspect of the participant's environment and then measuring the impact of the manipulation on the participant's behavior. There are actually two main types of experiments used by psychologists. One is a laboratory experiment and one is the field experiment. The laboratory experiment occurs, as it sounds, in a lab, and the field experiment usually occurs in a natural setting. So particularly with Baby Einstein DVDs, we could do a field experiment in a daycare, we could do it at a person's house. We wouldn't need to bring them into the laboratory. Some examples of what we can do in an experiment is to maybe test the effect of caffeine on test performance. Maybe we could test the effect of feedback on task persistence. We could test the effect of training programs on parenting skills. We could, test the effect of yoga on anxiety and stress. These are all things that have a variable that we can manipulate. In an experimental study, there are 3 things that we need to remember or that are important to the aspect of a study. One of them is the independent variable, one of them is the dependent variable, and the other is random assignment. The factor that the researcher manipulates is called the independent variable. This is the variable that the researcher believes will cause a particular behavior. The independent variable is the only thing in the experiment that is going to vary between the groups. The groups are going to be treated exactly the same except for the independent variable has at least 2 levels that can be manipulated or observed. And these levels are discrete values or conditions. Everything else is held constant. So with our baby DVDs, we decided in class that one of the manipulations that we could use is to either watch baby DVDs or to not watch baby DVDs. That's the simplest. It has 2 levels. Other examples of independent variables could be gender. These are not manipulated, they're just observed. So we can measure the outcome of some variable, say spatial attention, between males and females. So male and female would be an independent variable in this. Spatial attention would be the dependent variable. The dependent variable is the outcome variable. That's actually the variable that we're going to measure. When we make a hypothesis, we believe that the dependent variable will be related or will be caused by our manipulation, or the independent variable. Finally, when we conduct an experiment, we want to make sure that both groups are the same, except for the variable we are manipulating. In order to be sure of that, we need to place subjects in a group according to random assignment. And we do this by either pulling numbers out of a hat or assigning each person when they come in a new random number. But basically, random assignment will minimize any pre-existing differences between the two groups. But does it really matter? Let's take, for example, the experiment that we're going to run to see if playing Guitar Hero increases reaction time. So we have two scenarios. The top scenario, you tell me what's wrong if we allow people to put themselves into groups. If we do that, then we have the potential for all people who play Guitar Hero to be together, and people who don't play Guitar Hero regularly to also be together. Now we're not really sure if our hypothesis of playing Guitar Hero increases reaction time, because the people who play Guitar Hero may also play other video games, and therefore their reaction time may be fast, but it's independent of Guitar Hero. If we randomly assign them to the two different groups, then if there's any difference in reaction time, it will be washed out anyway, and so we will assume that both groups kind of stand on an equal level right from the start. So in experimental design, random assignment of participants in an experimental or treatment group as well as a control group helps to ensure that any differences between and within the groups are not systematic at the outset of the experiment. So basically we want to have individual characteristics kind of spread across both groups. Random assignment does not guarantee that the groups are matched or equivalent, only that any differences are due to chance. So why do we care? Because we have control, so we can treat the groups identically except for the independent variable. Furthermore, if we have random assignment, we can also talk about causal relationships, because any difference in the dependent variable, in our case language development with the Baby Einstein videos, should be the result of the independent variable manipulation. So again, according to our experiment, watching versus not watching baby DVDs. Let me give you another example. So consider an experiment with a treatment group and a control group. Suppose the experimenter has recruited a population of 50 people for the experiment. 25 were boys and 25 were girls. If the experimenter were to assign all of the girls to the control group and the boys to the treatment group, the results may be biased. So when analyzing the results, one might then question whether an observed effect was due to the application of the experimental condition, or was it in fact due to gender? And that will be important in the next slide. So let's look at a study that was done by Reichert and colleagues where they wanted to manipulate watching baby DVDs and see how it impacted word learning. So again, the experiment was looking at whether children do learn words from viewing baby DVDs or videos. So the experimenters sampled 96 children between the ages of 12 and 24 months, and they were randomly assigned to either watch Baby Wordsworth, which is one of the Baby Einstein DVDs, in their home, or to go about their normal daily routines. The participants watched the video for 6 weeks, and every 2 weeks their vocabulary was measured. Again, the researchers used the CDI, which is a measure of vocabulary, and were particularly interested in children's acquisition of the words highlighted in Baby Wordsworth. So in the Baby Wordsworth video, the video teaches 30 words for common objects and rooms in a home, and a picture of the object or room appears on one side of the screen, and a woman signing the word appears on the other side, while the word itself appears at the bottom of the screen. So according to the design of our study, we have two groups. We have the experimental group and the control group, and the children were randomly assigned to either group. One watched the baby Wordsworth and one did not. And their vocabulary was measured every 2 weeks over the course of 6 weeks. So we have random assignment into an experimental or control group. Our independent variable is watching baby Wordsworth or not watching baby Wordsworth. There are 2 levels. And then our dependent variable is vocabulary, a measure of vocabulary. Having a control group allows us to be pretty confident that if we find any increase in vocabulary, it's due to watching baby Wordsworth DVDs. What were the results of the study? The researchers found that there was no difference between the DVD group and the no DVD group. What they did find was that the younger the age when first viewing Baby Einstein, the lower their vocabulary scores. So, contrary to the claims that Baby Wordsworth improves children's vocabulary, the children who were assigned to watch Baby Wordsworth at home did not know or say more words than children who did not watch the DVD. Now, earlier we were talking about random assignment and what would happen if you put the same type of people in one group versus the other. So if we put all males in one group versus all females in another group. In this case, that would highly impact this study because as we talked in class, if we put the girls into the experimental group, they would probably have increased vocabulary just because girls typically develop faster when it comes to vocabulary. And that would be an intervening or a confounding variable because we could no longer assume that the Baby Wordsworth DVDs increase vocabulary if we did find it, because we know underlying that girls actually increase vocabulary sooner than boys do. There was a sort of outcome to this study, or fallout, we could say, in that the Campaign for Commercial-Free Childhood filed a complaint with the U.S. Trade Commission in 2006, insisting that educational claims be removed from Baby Einstein products. Furthermore, the American Academy of Pediatrics, because of the study, recommends that no screen time, there should be no screen time for children under 2 years of age. Finally, in 2009, 3 years after the study, Disney offers a refund for anybody who bought a Baby Einstein product. And here is Disney's response to all of that hoopla. Michael Eisner, the CEO of Disney, responds that we have no obligation to make history. We have no obligation to make art. We have no obligation to make a statement. To make money is our only objective.